Welcome to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Portshift.io. Portshift.io is a new sponsor to Developer Week events and is a Kubernetes native security platform delivering full visibility, vulnerability, and configuration management, compliance, and network segmentation. Before we get started with the speaker introductions, I'd like to remind all of our attendees that live chat and Q&A is available during the session, and that's to the right of the screen. And you can raise your hand in the chat and ask questions in the Q&A section of the webinar viewer. We will address your questions at the end of the presentation. Also, this webinar will be and is being recorded and made available and will be made available within 24 to 48 hours for additional viewing. So make sure to tell your coworkers about it after the fact. So, on to our speaker. Joining us today as your presenter is Ariel Shuper. Ariel is the VP product at Portshift, specializing in cloud-native based security for microservices. Ariel was the head of serverless security offering at Aqua Security, and prior to that, he spent 5 years in various roles at Checkpoint Technologies, focusing on security posture and network security in public clouds. Ariel has been a presenter at events such as Microsoft Tech Summit, Build, KubeCon, and Cloud Native Con, and various other serverless events. So without further delay, please give your undivided attention to Ariel.
Thank you very much. Hello, everyone. Good evening. And thank you for the opportunity to speak about shifting left security. So I know it sounds like a cliche, and also we're checking, how many people you have with you at home. So we know we need to keep you focused and to keep the tension high. So try to make it as interesting as possible. Many examples, real demos, available tools, anything which can help you fulfill this goal. And without any further ado, let's see what we prepared for you tonight. So what are we going to talk about? As the title of the webinar indicated, we're talking about shifting left. We want to talk about how developers can obtain security responsibility. We want to understand what does it mean, security responsibility? Security responsibility for what? What is covered? What is the new domain of responsibility? What is under the hood that this term we need to worry about? I'll talk about how to automate all these security responsibilities and how to add it into the developers' workflows, whether it's CI, CD, and how even we can automate runtime security and make it part of our DevSecOps practices. We'll show some tools and examples and show some live demos, and we'll be happy to answer questions and elaborate on items that we move in. So we prepared the pack agenda, a lot of interesting things. Stay with us and hope it's going to be interesting. So, developers are the new security guards. Sound interesting. What does it mean? We all know that we want to shift left security. We shift everything left. We also want to shift security into the directions. And cloud native security really requires this paradigm shift. Why does it require this paradigm shift? Because it's much more efficient. Developers team know their apps better than SEC team, so it's always faster and easier for them to respond, to identify, and to fix issues. Developer teams, as I said, are more agile, so they're working in agile processes. They can modify, they can fix issues, they can find, and while they are developing the code, it's the best to find issues and to solve because it's much more efficient, it's less expensive. If those issues are discovered long after they finish developing their code while they're working on some other applications or other features, it will be much harder to bring them back, to try to remember what they did, what created, what package they've been using, what needs to be replaced, test it all over again. It's always best to detect, identify the issues when it occurs, when it's hot, not to wait or postpone it until it's becoming something that no one is remember what did it do or what needs to be fixed. So obviously, there's nothing new here. It's common. I think it's practice, and especially in working in a cloud native approach that we're trying to be agile, we're trying to be fast, we want to add more features, distribute it into small components. It's critical that developers will take more active role. So that's, of course, great. There's a great intention, make perfect sense. But there are some challenges because in reality, there is a gap. There's a gap in the knowledge, in the expertise of what's important, what's not, what might have an impact, what might not. The problem solving isn't really defined well because in traditional world, when we have networks and we had hosts or operating systems, it's kind of the borders were very, very clear who's doing what and what's need to be done. When we're talking about we're talking about pods, distributed architecture, a lot of different microservices, then it's become blurry again because the host's not really relevant, not really important because I can have the same pods running on different hosts. Even the pod itself, we need to make sure how we deploy it. We need to make sure who can communicate or how they communicate with others. What's the internal communication, what's come from external communication. So it can become a little bit more complex and harder to define, especially if you're running in a flexible environment like Kubernetes or any type of its distributions. This is something that really need to, have to be some time spending, understanding, and configuring. So the problems really need to be defined very well, and we need to create different tool sets, something that is intuitive, easier to understand, even to those who doesn't have a master degree in security, something that would be easy to implement, can be part of the development life cycles. So there is a need for a new, as we said, paradigm shift, and really require significant changes in the way we do and measure security. So let's start. Let's first start with defining what's a problem statement. What do we need to do? What do we need to cover? What do we need to be aware of? So when we look at containers, as a primary example, maybe the primary environment, there is the prime suspect. We need to look at the code itself, right? The code can sometimes bring with it lots of vulnerabilities because we package multiple things. So either in the packages themselves or in some dependency that we refer to in our code. In all those libraries, we can find different vulnerabilities. They can vary in their severity, they can vary in their impact, they can vary in their correlation with the operating system. But the code is the primary suspect where potential vulnerabilities that can be exploited afterwards might occur. But it's not it. There is more than just the code. The container deployment is critical. Is it critical for the security posture of your environment? Why is it critical? Because it's important to see and define what privileges our container has. Traditionally, in the early days of Docker, containers were running as privileged. We can find containers running as a root. We can see it, for example, we can check the volumes. Did I try to mount all the volumes? Did I try to mount the host path and get the host file system as part of my container volumes? What am I trying to do with the host network? What I'm trying to expose? And is anything like that I can isolate my container from the host and maybe perhaps apply some other tool that like SLinox or SecOp that can provide this isolation. So the deployment itself is also a critical piece in our security posture creation. But it's not it, because the pod doesn't live by itself, doesn't live, on an island. There is a cluster, and the cluster has, its own configuration. So we need to make sure what roles are we setting up, what role binding, what do we do, what do we give who, right? What are the secrets? Of course, it's a very powerful secret mechanism. So we can only inject the secrets while the pod is running. So it's going to be in the memory, not on the disk. So it can be much safer. But again, we need to make sure that we are using this mechanism just as expose, secrets in config maps or environment variables. We don't just leave, access keys or secrets or passwords. I'll show you some examples of things which are publicly available and just people forget those available. And why not? Why want to keep it? If you want to go deeper than that, then API calls, authorization, we can maybe authorize what can be done or not on the cluster resources, and not just, the pods themselves. And there are many elements that need to be taken care of when we configure and want to keep our cluster secure. Last but not least is also the network. Network is an integral part of our security because obviously we need network for pods to communicate, but this inside the cluster, we need also to configure who can access from the outside and what we want to expose, what we want to authorize, especially if you want to create like multi-cluster communication, or if we want to communicate with cloud services. We want to try to maintain some level of security on the network itself. So when you look at it, all in all, there's like a big piece of configurations and information which need to be done. If you look more in the illustrative way, then, when you look at on my right-hand side, you can see the worker nodes, which has multiple pods, right? And those pods are obviously the prime suspect where we focus most of our work trying to find vulnerabilities, but they're not by themselves. At the end, in Kubernetes, it's an end-to-end game, right? And we just have to look at them. We need to look also in our cluster. We need to look who can access, what they can do, what permission they have, what actions they perform, right? Even if the permissions are okay. So there's a lot of things that we need to take into consideration, and there is a big knowledge gap and expertise that need to be covered. So the best way to address it is, of course, try to add more tools and more discovery things before those risks may happen. And if we want to kind of make sure that we succeed in shifting left, and we succeed in moving this responsibility to developers, to architects, to our bringing closer to the goal that we discussed in the beginning of this presentation, then we obviously need to stay close with developer tools, stay close with the pipelines, the processes they do. If you want to succeed, we need to add the applicable tests to those processes, and then obviously it will be easier and faster to detect potential risks before they happen. It will be easier and faster to find them, to mitigate them, and can keep our cluster and deployment secure. So if you want to talk about things like our DevOps tools, that's the great way where we want to embed security checks. If you talk about our continuous delivery, that's a good place to check for security context of deployments, secrets which are exposed, roles which are overly permissive. In the continuous integration phase, we probably want to check for vulnerabilities, authentication of images, so we can verify that only authenticated images can be deployed in our cluster. So there are many things that we can do in order to reach this high level of security that we are targeting and we want our application to run in. Before I start and going more deep dive into that, I wanted to get a quick poll and get your thoughts, and if you can share with me, what do you do today in your CI/CD pipeline? Are you doing vulnerability scanning to your images? Are you checking for exposed secrets, risky roles, security context risk, or all of the above? Would love to get your feedback, see what you guys are doing today. Okay, hope everybody had a chance to fill in the answers. Give you one more second and we'll move ahead. Perfect. Let's move. Okay. Let's talk about how do we automate and how do we bake our security into our pipelines. Let's start. So the most classical and probably the most common practice is to scan images. Okay, that's easy. We can automate scan of the images. Well, we build those images. We can verify if there's any known vulnerabilities in the software packages or dependencies of our image. There are some tools also scan for malwares or backdoors, looking for kind of hashes which are created. There's a lot of open source tools that are built for this purpose, and it's pretty much very easy to add this step in our pipeline. Sometimes people even can define policies like on certain threshold of vulnerabilities. They want to fail the pipeline. They want to block the ability to create an image, and then developers will have to fix. Some just report, some just create a Jira ticket. There's lots of different options. What you do, but this is probably the most common practice. But we need to remember that it's easy, it's important, but not all the all the vulnerabilities that we do find really are exploitable or has some relevance. There's a lot of vulnerabilities which we discover, but there's no relevance to your code. So it's definitely an important step, but it's not the only step which is recommended to take. So this is just kind of a list of the available tools. So Anchor is a popular one. Claire by CoreOS, now Red Hat, is a very popular tool. Trivi by AppSec is a very good example of an easy to use open source tool. There's also Docker Scan. So it's relatively easy to find. There is a lot of tools, and all can be used in part of your pipelines. But as I said before, we need to remember that there's lots of vulnerabilities. You still need to filter it smartly. And not always there is a correlation between what you find. So for example, take a look. This is a scan which I took from PortShift that when we scan code, and I just took a few examples. I used publicly available example of public applications like booking info, which is used a lot in the Istio, or just sample applications. And as you can see over here, I was trying to filter them from medium and above, right? And you can see like 251 vulnerabilities or 227. There's a huge amount, right? Are all those vulnerabilities relevant? Probably not. Why not? Because sometimes they're relevant to specific Linux. Sometimes it's a specific distribution. Sometimes they're relevant for objects which you don't even have in your code. So vulnerability scanning is important, but need to remember it's not the whole picture. It's not the whole thing. There is more that need to be done, and even in vulnerabilities, not all of them are really critical or really relevant to your code itself. So let's move ahead. What else is on the table? What else can we do? We probably want to add more context. We want to not just to scan the image itself and to verify, but to also see how we plan to deploy it, where we plan to deploy it, what permissions do we have. And the continuous delivery pipelines are a critical component in our journey for secured environment. Why is it critical? Because it's a great opportunity to discover potential risks before they occur, right? Before they happen. When we start scanning deployment files like Helm charts, Terraform modules, we can always get some visibility into what is going to be deployed before it surprises us, before it's actually being deployed, which is critical because sometimes when it's already deployed, it can be a little too late for us not too late. It can be, of course, detected when it's deployed, but it's always better to avoid risk before it happens. Now, when you ask me what can I find in the deployment file, so I spoke about it before, security context of your pods, of your deployments, of your stateful set, and security context, I'll show you in a minute. It's how you define your privileges. So you want to make sure nothing is running as a root. It's where you define, what volumes you can mount, or you can find, what correlation you have with the host file system. So all of that is critical to detect and making sure it's done properly, nothing running as a root. We can look at all the roles. We can see how many cluster admins we require, how many elements can change our config map, can modify, update the cluster events. And as I spoke before, secrets, always a great thing to define it. Those are just examples. I just found publicly available. I used the new tool that J4 released, the Chart Center, where you can find multiple Helm charts. So I just took popular charts, and for example, I'll show you in a minute. You can see that someone just forgot his, Postgres password exposed, and I can find the Redis password exposed without hiding it, without using, more like the secret mechanism or any other tools. So obviously, it's always better to find those in advance, to hide them and prevent them from being deployed like that and being exposed to everyone. Let's make a quick demo so we can see it in live. What do I mean? Great. So this is an interesting open source tool, the JFrog chart center. You can find multiple Helm charts. I just took popular stuff, but you can see there are lots of different Helm charts available. If I go back to the let me just go back to the homepage so you can just really find, I just was playing with different things, but start with the Helm charts. You can find many Helm charts. There are feature ones. There's close to 30,000 different charts available. Now, I obviously started playing with it, so I downloaded a few of them and tried to deploy it in my cluster. So let me just kind of this is the certain namespaces. Certain namespace that I deployed. It's called Tomer. And then when I deployed it, I started, let's scan it. So we portrait-located a scanner, a Helm portrait scanner that scanned those tools. Let's see some interesting examples of what can be found. So I took the airflow as an interesting thing. You can see over here that we failed this deployment because we found high risk. We only allow low risk. So obviously, if I can change it, then it will be easier to deploy. But at least it'll be good to define or to find the risks. So you can see the different risks. A lot of those risks are low. Like we found secrets which are not exposed or doesn't contain anything. But there are some interesting things. We found some medium risk and permissions that someone can has write access to resources in the cluster. Okay, in this case, it's not critical, so we just left it as a medium. Another example over here is high risk in the security context. You can see that we have some deployments which have security context, which have privilege escalation on, so people can maybe even if you deploy your pods with regular, but if someone managed to break in, it can alleviate the privileges and reach like root or privilege. They can get access to all the host resources. So you can see that there are some issues here or the ability for a user to be root, and there are some other issues as well. So we can we block it. We'll do the same thing, but instead of defining as minimal low, I will define it as high. Then I'll be able to deploy it even if you have those risks. I'll still get exposure to the risk, but the deployment succeeded. So of course the user can play with it and define what he wants. But now, if you want to see like some more information about what we found, and then you can see why we consider it sometimes medium, sometimes low, then you can see that people just left their the Redis password or just left their Postgres password exposed. Probably be better to get it, to get it hidden or to use the secret mechanism. If I just look for this, high, for the high risk, so it comes with, the security context. Someone defined, the security context. Let's try it over here. Let me just go quickly. Yeah. So you can see the security context was defined over here. That's the high risk we found. And obviously there's some more, there are more elements that can be found. So it's just one example. If I go back, let's play with a different chart. Take MongoDB, for example. Again, I'll keep it as maximum risk low for this time. You can see that in the Helm charts in MongoDB, we also have some issues. In this case, we have a high risk because, again, privilege escalation is on. User can escalate privileges and become root if it's deployed like that without modifying the security context and changing the privilege escalation into false and preventing it from deployment. So again, those are just kind of simple examples of things that we deploy into our cluster. We deploy like a database, or we deploy some tools, but it's always better to find them before they become real risk, before they become real deployments. So we define the trigger or the threshold that will allow us to stop it and prevent it from deployment. Cool. So go back to my slides. Okay. Just a second. Stop sharing my screen. All right. Let's go back to my slides. Great. So we talked about CI/CD and explained why it's important to create early detection. But if we keep up with our shift left paradigm and we want, again, to empower developers and verify that they have some tools, let's talk about the runtime, because obviously making those tests before we create our images, before we deploy them, is great and it's important, but we cannot stop there. We need to continue, because security is not just adult development. We need to move on, and we need to get it constantly, even when the pods are deployed. And then comes the question: what can you do in the runtime? What's there? So I want to introduce one more thing. This is the QB. It's an open source tool that Portshift created, and it's available for everyone. And the of QB is to do some different scanning. So scanning is always great in the CI/CD, and sometimes can be even in the registries. But as I just showed an example, not all the things you deploy in your environment come from your pipeline. Not everything is thing that your developers wrote. Not everything is an application. Sometimes you just deploy, kind of performance metrics. You deploy performance monitoring. You put some tools to verify your network. Sometimes you want to deploy whatever, a log collection mechanism. So there's many tools which you can deploy, and you want to make sure that not everything came from developers. But again, you need to verify that whatever you deploy in your cluster is not vulnerable. Sometimes you want to make sure that your Kubernetes elements are not vulnerable, whether it's Kubernetes or OpenShift or any other distribution we choose. You want to make sure that those are not vulnerable as well. So not always those images come from your registry. So it's always important to get visibility into your Kubernetes elements and not just assume that everything is okay because you automated all the processes when started. So this is why we created QB. Okay, so QB is something that you can deploy in your clusters. It will give you an immediate snapshot of what elements you have in the cluster which are vulnerable. What elements, whether they are worker nodes, application pods, or just your kube systems and your Kubernetes environment could be vulnerable. You can see your example over here. I'll just share my screen one more time so I can take you to our GitHub page of QB. We'll share, of course, the URL. It's easy to find in GitHub. And again, the idea is it's an independent tool. You can run it in your cluster. You can define what is the level of vulnerability that you want to see. You can set the max parallelism level, so you can run like multiple jobs. They can be very quick in giving you an accurate snapshot of your risk. And you can also configure the severity threshold. For example, you want to see higher critical vulnerabilities, right? And then you run the scan. You get this HTML report to show you all the pods, the pods, the namespaces, and then what was found. If you click on it, you get even more detailed information of what package, what fixed version, and of course it's recommended to do it automatically. So this is something that you can automate in your deployments and then run it, and it doesn't consume resources. Only when it's started, spin up those jobs, clean up when it's finished, and it's very efficient. So I encourage everyone to use it. It's free, it's open source, it's available for you to use. Going back to my slides. Perfect. So this is a great example. Another example that we want to talk about is roles. Okay, we scan the roles in the CD, but it's also important to see what things are deployed in your environment. And here too, given the fact that the roles are working, like in the fact that you have users, okay, or group or service account, there is a role binding. Okay, so you bind to those user, group, or service account roles. Those roles grant you permissions to do certain things on certain resources, like get or list on pods. It could be on other cluster elements. Obviously, this is something which is again important to verify and important to be aware of when you deploy. So it's something that you constantly need to monitor, just like your images, also the roles. Why? You ask yourself, why is it so important? What can go wrong when using roles? And obviously, you can see that sometimes you can find too many users, which get too many capabilities, verbs, on too many resources. So it'd be kind of surprising to find too many users who can modify your endpoints, create clusters, create maybe pods, open services, modify them. Then obviously this is something that you want to be aware. You don't want to find too many cluster admins or too many service accounts that can create or create too many resources. You want to probably limit it to in basic between namespaces, but you also maybe want to limit what you can do on what. And this is why it's something which is important to verify, to constantly monitor. But we need to remember that shifting left is not just scanning of static things. We also need to be dynamic. We also need to be more looking at our network, looking at all the other elements. And this is something that something which I'm sure a lot of organizations use, but we want to be aware of the thing that can be done different. And in shifting left and talking about runtime policies, we want to make sure that everything can be automated and everything can be done in advance. And in having said that, I think one of the nice practices that we start recently to see is where developers create their own app security policy. So I can let developers, when they create the application, they know the best what are the characteristics of their code, which microservices need to communicate with which microservices. They know what permissions they need to create for them. They know how they want to deploy them, where they want to deploy them. Then it makes a lot of sense that developers will also create a manifest that will allow them to then turn those runtime policies of the pods, runtime policies of the deployments, of the network policies, of the roles, which we want to grant them, and everything can be packed together. At the same thing, we also want, let's say, our DevSecOps teams, the one who has maybe more knowledge or more expertise on potential attacks, or have seen different attacks or exposed to things, to malware, things that can go wrong, to be able to set their guardrails, to be able to set, the overall governing policies, like what URLs cannot be accessed, who can access my cloud storage, who can access the clouds that store database service. All those services need to be then again enforced globally. For example, that maybe only encrypted communication can be allowed. So we want to be able to allow developers to define the basic or the fundamental elements of their application. On the other hand, we want to give the SecOps team to create the guardrails, which are the basis for all the other policies to live within the space. And having this capability is something which is critical. Why is it critical? Because it will allow us to move fast, allow us to be as accurate as possible, to minimize the potential risk, and again, maintain the best practices. So how do we do that? What's the best way to do it? So the goal, the vision that we in PortShift see in this space is, of course, let developers create the app security manifest in the deployment, in the continuous delivery phase, when they start, planning the deployment, creating a deployment manifest. Okay, allow the DevSecOps team create guardrails, which of course will be added to those deployment, will be of course governing those deployment and maybe supersede or having the ability to change and modify, and then incorporate those manifests, okay, into runtime policies. So we can have resources in our cluster which are responsible for this runtime policy, responsible to update the network policy, update the deployment, and the ability to, with mutating webhooks, to change and modify the deployment. And then we can have everything together, take those policies, run them, and then have the custom resource who enforce those policies and deployments can create and enforce them in runtime. And this is something which will give us high level of security with the highest agility and the highest speed which is available. So this is something that developers will be able to know what APIs are exposed, what API details, what workload they can access, what API they can connect, what privilege they need, and then what cluster permission they're looking for. And our DevSecOps team will be able to have their own characteristic, what work environment they need to run on, what connections or what type of connections, what security guardrail we need to use. For example, no one can run as a privilege or as a root as a basic. You can limit what volumes you can mount to your pods, but all together can be reflected and can be built and combined together. So I want to show you an example, a simple example. So you can see over here like deployment rules. You can see connection rules. People will define what they need, will define who can access what, and then everything will be translated into security policy. So let me show you like a quick example. So again, if I just take the same policy that I just showed over here in PortShift, for example, we allow users to take these kind of policies and then map those policies to deployment rules. We can see over here related to the different applications, to connection rules, which again apply to the same applications, and then everything can be deployed as a runtime security. So that's about it. Any questions from the audience? We'll be happy to address.
So Ariel, this is Patrick again. Great presentation. Thank you very much. If you want to click over to Q&A new, there are 4 questions. I did pull them from different sources and put them on there for you. I'm not sure if you can see them. The first one is, why do we actually need the parallel scanning?
Okay. If I'm trying to understand, okay, what's the difference between parallel scanning? I would assume that you probably refer to scanning in the CI/CD and scanning in the runtime. So I think the answer, if I understood correctly the question, then my answer is there are 2 reasons why we want to do multiple scans. One reason is because the vulnerabilities, are not static. Sometimes there are new vulnerabilities which are discovered, like 0 days or some newly discovered vulnerabilities. So even maybe perhaps by the time you scan your image in the CI/CD, it was perfect, but then when it was deployed, something else was discovered. This is one thing. And the second answer is that the scope of the runtime is sometimes broader, because in your pipeline you discover the application code, what your developers develop, and in the runtime you also scan some other tools that someone deployed, because you found some nice scanning, or because you signed a contract with some vendor that have tools, or you have a log collection. So sometimes those tools might be vulnerable as well. Sometimes your Kubernetes can be vulnerable. If beginning of June, there were 2 new vulnerabilities discovered in Kubernetes, which impact everyone. Just so you point to know what CNI are using in this case, or what packages, or what kube. If I'm remembering, it was kube. Okay, not for example the tool which was discovered. So sometimes your Kubernetes itself could be vulnerable. So you want to get this an accurate snapshot of what's your risk, the relative risk in deployment. Perhaps it's better to do multiple scanning touching points. Okay, and then the second question: do you have possibility to scan the rules in administration controller, OPA? So the answer is we are working at a similar level like OPA, that you can really scan the rules in the admission controller. We can verify what we can do. We can accept those rules, the manifest that the developers create, and translate into real rules, into runtime rules that's related to how you want to deploy in your connection environment. And then I see another questions.
Hold on a second, Ariel. We just had there's a poll we've asked all the attendees to complete really quickly. A poll for the webinar meet your expectations.
Sure.
So you can now continue. Sorry, didn't mean to interrupt there. So that's the next question. If you wanted to hit that next question.
Okay, perfect. So I'll just a minute later. Okay, and the next question is, how can we isolate vulnerable pods? Okay, that's a great question. And it's a good question, because sometimes we discover pods which are vulnerable, and then until we fix them, until we replace them, it takes some time. It's not a lot, but it takes some time. We don't want to keep exposure to those vulnerabilities. And the answer is, at least in PortShift, our system, when you identify a newly discovered vulnerability, give you suggestions for network rules for how you can isolate it. So you can start from, we give you different suggestions. Sometimes maybe you want to isolate it from external communication, so that that no one can exploit this vulnerability. Sometimes if we set you're communicating with a sensitive resource, we'll suggest you to stop communicating. And if it's critical and something genetical, we sometimes, depends on the context, also some offer you the option to completely isolate and prevent communication of this pod with any other resource. So it depends on the deployment, if this pod is exposed, is part of a service which is exposed to the internet or not. So based on the context of the pod, in PortShift we offer different quarantine options. So you can always select your desired result, and we'll automatically implement it, and create this policy and implement it in the cluster. So it's a very good question, and I think something that is important. How should we allow pod reader rule? So obviously, if it depends on the verbs, right? So there is you need to define what you want to allow, and then based on what capabilities you want to give it, what verbs, on what API, that will determine what role the pod will have, or the service account in this case. So there's a lot of information about that in PortShift. We just if we find that you're giving too many roles or too many permissions, we're just going to give you an alert about that as well. Okay, do security produce any latency during build stage? So the answer is yes. It has some latency, because you want to scan, you want to get results. So I don't think that build stage are sensitive to latency. There are obviously some latency, but not something significant. Depends on the size of the image, and nothing nothing dramatic. Last question. My question didn't have a full sentence. Sorry. Okay. Security scanning. Okay, perfect. So I think I answered it as well.
It looks like that's the only questions that you have. Some really good questions there from the audience. Ariel, thank you very much for your time today. It's been a great presentation. And then I'm just going to, before we finish, I wanted to thank you as well as PortShift for your sponsorship of today's online learning session. And I also want to remind all of our attendees that there is a recording of the session will be available in 24 to 48 hours so they can review this. Ariel, is there a slide with your email contact information on it, possibly in your presentation?
Good question. No.
Can you just list out your email address for all of the attendees, just in case they wanted to connect with you?
I'll be very happy if you connect with me. I'll just take my message. So it's very simple. It's ariel@portshift.io, but you can also see it now in the chat. We'll be happy to get contact. If you contact us, feel free to contact us for more questions, more information. And just in the worst case, just go to our website and post your questions. We promise to go back as soon as we can.
Terrific. And the attendees should look for that updated with the recorded version coming in the next day to 2 days. They can then forward that on to their coworkers, to the groups that they're working with. The recording will also be available on devnetwork.com in our Developer Week content archive. So that will be available for the next 180 days. So additional attendees can check out the recorded session, and of course connect with you, Ariel, as well as PortShift if they have any specific questions. So I want to thank all of our attendees as well as Ariel for your time today, and I want to wish everybody a great and happy and healthy day. Bye now.
Thank you very much. Thank you.